Question 5G is a little different. What we need to do here, this is still an inverse trig. So actually if you look at this, this is the square root of e to the x over 2 squared plus e to the x squared dx. And again, if you'd prefer to look at it again a slightly different way, we can see this as 1 over 4 the integral of e to the x times 1 plus e to the x over 2 squared. So what is going on here? What does this look like? Well, this looks a lot like our tan inverse, right? When we had tan in d dx of tan inverse of x is equal to 1 over 1 plus x squared. But hold on, this time we don't have a 1 on the top, we've got an e to the x. Is that going to cause us any problems? Well, what would happen if we differentiated tan inverse of some function of x? What would happen? Well, obviously you'd still get your 1 over 1 plus f of x squared, right? But then the chain rule kicks in, and then we get f prime of x being multiplied to that. So you end up with f prime of x over 1 plus f of x squared. Now, if I say that this is my f of x, which is e to the x over 2, or half e to the x, then what's f prime of x? That's also equal to a half e to the x. It's exactly the same, right? These two, f is equal to f prime. And this then starts to look a lot like f prime of x. So what do we actually have? What we actually have here is, a half, and I'll take one of these halves back inside to give me a half e to the x over 1 plus a half e to the x squared dx. So now I know exactly how to integrate this one. This gives me a half, and then this is my tangent inverse of this function. So tangent inverse of a half e to the x plus c.